Okay, for part 3 of this lesson on the origins of civilization, we're going to consider some other theoretical frameworks for thinking about issues of cooperation and coordination in human societies. And by coordination, we mean settling on agreed beliefs and practices that allow people to get on with each other and interact successfully. And the first one we'll think about is the idea of how weak biases can create strong outcomes. And the key theorist here is Thomas Schelling in the 60s and 70s. One of his things was how once he went to deliver a lecture in a lecture theatre, and at first he thought nobody had turned up because all the seats at the front were empty, and it was only when he looked further into the hall that he realised that there were people to come for his lecture, but they were all packed at the back. And they left all the front seats empty, and he commented on this to his host, who said, well, the thing is that all the students, they don't want to be at the front, each one wants to sit behind somebody else, and so with that desire to sit behind somebody else, it ends up leaving all the front rows empty. And so he was interested in this because it shows there's a fairly weak bias. People don't want to sit at the back. They just want to sit behind somebody else. They just don't want to be at the front. But so it's a fairly weak bias, but it produces a very strong outcome that everybody is absolutely packed to the back and it fills up from the back. And we saw another example of his concern with how weak biases can produce strong outcomes in the lesson on computational methods, and particularly the part on agent-based modelling, where he was interested in neighbourhood segregation. And we saw how he studied this with a grid. I've only shown part of it here. In fact, I think he used a chessboard, and he used coins, which we can imagine as being heads and tails, representing two different communities. And in his rule, each person, if this represents a person, wants to have their neighbours to have at least 3 out of 8 are the same as themselves. So they're not asking for a majority. Certainly not asking for everyone to be the same as themselves, but they're not even asking for a majority. They're only asking for at least 3 out of the 8 neighbours to be like themselves. And so that's a fairly weak demand, and yet what he finds in simulating this, allowing people, because there will be some empty squares, so allowing people to move to an empty square that satisfies that demand. If it doesn't satisfy demand, they allowed to move to another square instead, that you end up with the board being completely segregated into all heads here and all tails there. So a weak bias produces a very strong outcome of neighbourhood segregation, even though the individuals don't want segregation per se. They just want to feel comfortable that they've at least got a reasonable number of people like themselves in their neighbourhood. It forces a much stronger outcome of neighbourhood segregation. So these agent ideas can suggest how civilizations might arise through simple rules of behaviour, then produce these emergent properties that we identify as the beliefs and practices of that civilization. Another approach that's been adopted is that of natural selection. So this is based on ideas from biological evolution, where a successful gene propagates through the population and so comes to dominate. The idea here is that the same thing explains how culture evolves, so that a successful cultural trait can spread through the population because it is helpful to people. So Richard Dawkins invented the term meme to describe this. A cultural trait that corresponds to a gene. So it's an elementary element of behaviour, like a particular style of cooking or a particular style of architecture, something like that, that comes into existence, and then if it's successful, if it proves beneficial, it will propagate and be adopted everywhere. So that style of cooking becomes typical of the whole group, or that style of architecture becomes typical of the whole group. Now the term meme has come to mean a different thing today, or has got a specific internet sense to it, but in Dawkins' original idea, meme was like the cultural equivalent of a gene. Other people have used other terms for it. For example, culture gen. Boyd and Richerson have done a lot of work on these ideas. Their book is called Culture and the Evolutionary Process. But they're using the mathematics of Darwinian evolution and applying it to culture, just replacing gene with meme or culture gen, as they call it. But it's an elementary cultural trait. But they can't just take over the mathematics of Darwinian evolution wholesale, because cultural traits, memes, if we call them that, or culture gens, behave a bit differently. So let's just have a look at some of the differences from biological evolution. So the first thing is that you can have horizontal transmission. So what do we mean by that? Well, in biological evolution, you inherit your genes from your parents and you pass them on to your children. So it flows down from generation to generation. But that's not necessarily the case for memes or culture gens or cultural traits. You can learn them from your peers, or you can learn them from other adults, or you can even possibly learn them from your children. So as new cultural ideas come in, they can be transmitted in all directions, not just from parent to child. So that's one thing that they have to take into account. Another issue is that it's a lifelong process. So in biological evolution, you get your genes from your parents, and that's a one-off. You then go through your whole life with those genes. But in cultural evolution, you can be acquiring new cultural traits all the time. And you can swap out the ones you've already got for new ones as they become available. And another issue is that the changes or the new cultural traits can be the result of deliberate thinking, purposeful. In biological evolution, we imagine that new genes arise purely by chance. But in cultural evolution, people could say, oh, look, here's a better way of chipping away this flint to make a tool. And so they can use their brain, and then they create a better way that can then be adopted by other people. So it can be driven by deliberate conscious intelligence. And a last point is that you transmit the actual behaviour. So in biological evolution, you transmit the gene, which then causes you to have blue eyes, or to spin a spider's web if you're a spider, to exhibit a particular type of behaviour. So there's a difference between the thing that's transmitted, the gene, and the manifestation of it in particular behaviour or particular attributes of your body or what have you. But with culture, it's the actual behaviour that you transmit. So if we could use again the example of chipping flint tools, you see the person chipping a flint tool and you say, oh, that works well, and then you copy what they did. You're not passed a rule book that is transmitted. It's the behaviour itself that's transmitted. So these are the kinds of differences between cultural evolution and biological evolution that people who've adopted these natural selection approach to understanding the propagation of cultural traits have had to contend with. And so it's not just taking over wholesale the biological mathematics, but it's adapting it to these conditions. And one of the implications of this is that cultural evolution is faster than biological evolution, much faster, because it's lifelong, so and it's deliberate, so you don't need to wait for chance things to occur which might happen once every 1,000 years, and that it's only passed to you the moment of your conception. You're constantly learning, and you can be deliberately thinking about what to do. So this makes things happen much faster, so cultures can change over matters of decades or centuries, not millions of years. And you can also incorporate into these models the idea that the fitness, so it's the survival of the fitness of a cultural trait depends on what others are doing. So this is how, to some extent, the cultural traits can be arbitrary. It's not necessarily that this way of doing it is the best way of doing it in an absolute sense, but it's the best way of doing it if that's what everyone else is doing. So if it's not necessarily the case that driving on the left or driving on the right is absolutely the best way to do it, but if everyone else is driving on the left, then it's a good idea to drive on the left. And if everyone's driving on the right, it's good to drive on the right. So the fitness of a cultural trait can depend on what other people are doing. So you can build that again into these models. And then a third framework for thinking about the emergence of cooperation and coordination in human societies, I'll put under the heading of the evolution of cooperation. This is the name of a book by Robert Axelrod, political scientist, and he's using game theory. So game theory is about situations where you have to make a decision and the consequences of your decision depend on what other people decide to do. So for example, in the game of chess, you're looking at the board and you're deciding which piece to move and which square to move it to. And but when you're doing that, you're also thinking about how your opponent is going to react, because yes, it would be great to move over there, but then they could take you. So you've got to think not just about what you do, but what the other person is going to do. So game theory is to solve situations like that, to think about what's the best strategy to take, knowing that your opponent is also thinking about what the best strategy to take is. And the particular game that this is based on is the prisoner's dilemma. So this is a scenario that's pretty well known, but I'll go through it anyway. So the idea behind it is that we've got two prisoners in the police station who have committed a crime, and the police are interviewing them to try to pin it on them. and they present the prisoners with various options, and the prisoner has to decide what he wants to do. So the best way is to draw up a little table to show the issues. Okay, so the police have the two prisoners in the police station, and we'll call them prisoner 1, P1 here, and prisoner 2. And this table shows the options available to them. So the police go to the first prisoner, we'll see things from his perspective, and say, if you confess to the crime while your colleague doesn't confess, remains silent, then your confession will help convict him, and we can get you off for that. So you will get no jail time. So if you confess and your colleague remains silent, you will get no prison time at all. And on the other hand, he will get 10 years because he didn't confess. He chose to remain silent. So, but of course, if you don't confess, if you choose to remain silent and he confesses, then he'll get off scot-free, but you will get 10 years. So we represent that as a minus 10. It's a negative. It's a punishment, not a reward, not an advantage. So you get minus 10 points. You get 10 years in prison. But on the other hand, if you confess and he confesses, well, you're not going to get off because you both confessed, but at least you'll get some credit for the fact that you confessed. So if you both confess, you'll get 5 years in prison. So we represent that as minus 5. And on the other hand, if you both remain silent, well, of course, we won't be able to get you for that crime because they haven't really got the evidence. But what they could do, we do know that we caught you in a stolen car or something. So we can't do you for the bank robbery, but we can say that you were in a stolen car. So we can get you for a smaller offence. We can definitely pin that one on you. So you'll get 2 years in prison for that. So this is called in game theory the payoff matrix. So in each square it shows the payoff, and this is from the perspective of prisoner 1 just. So prisoner 1 has 2 options, and he's got to consider that what the outcome of whatever he chooses depends on the 2 options for prisoner 2 and what he chooses, so that we've just been through. And so what should prisoner 1 do in this case? Well, let's suppose that prisoner 2 is going to confess. Well, if prisoner 1 confesses, he'll get 5 years in jail. If he stays silent, he'll get 10 years in jail. So it's a bit of a no-brainer. If prisoner 2 confesses, then prisoner 1 should confess as well. And then what if prisoner 2 remains silent? Well, if prisoner 2 decides to remain silent, prisoner 1, if he confesses, he'll get off scot-free. If he remains silent, though, he'll get 2 years in jail. So again, it's a no-brainer. He's going to go for confessing. So whatever prisoner 2 does, it makes sense for prisoner 1 to confess. He doesn't know what prisoner 2 is going to choose, but whatever prisoner 2 chooses, he'll be better off if he confesses. Obviously, you'd like prisoner 2 to remain silent, but he can't rely on that. Prisoner 2 is probably going to confess. But so for prisoner 1, it makes sense to confess. And of course, the same applies to prisoner 2. He's going to think through in exactly the same way and decide that it makes sense for him to confess whatever the other guy does. So the result will be that they will both confess and they'll both end up with 5 years in jail. But if they had only both chosen to remain silent, then they could have both been better off. They'd have both only got 2 years in jail. So it's kind of a shame that they both reasoned that they ought to confess, because if they'd only both stayed silent, they'd have been better off. So this is the dilemma. the dilemma is, you know, he's thinking, well, could I trust the other guy? But should I stay silent? Will he stay silent? And you'll think, well, probably I can't really trust him, because if he thinks, well, you know, my mate's a good mate, he'll stay silent. I'll confess then, and I'll get off scot-free, and then he'll be banged up for 10 years. So, you know, I'll probably get away with it. By the time he gets out, you know, I'll have moved house and he won't know where to catch up with me, that kind of thing. So all this is going to be racing through his head, but they're going to end up confessing, and they'd be, as a result, worse off than if they had both remained silent. And in game theory, these options are known as defecting and cooperating. And the same here, to cooperate or defect. So they say if they both cooperated, trusted each other and cooperated, they would be better off getting just 2 years in jail. But when they both defect, they're both worse off. They get 5 years in jail. And of course, if this one cooperates and the other defects, here confesses, that's a defection, the defector does well out of it, getting the highest payoff, if you like, with no years in jail. But if the other one, if this one decides to cooperate and that one defects, then it's known as the sucker's payoff. He gets the worst possible outcome. So this prisoner's dilemma leads the prisoners both to defect rather than to cooperate, going through the reasoning of what's the best thing to do. So this is the prisoner's dilemma. And though it becomes interesting when you go to the iterated prisoner's dilemma. Which is when this scenario comes up over and over again. Because in this case, you have the possibility to show your partner that you can be trusted. So if you show that you cooperate the first time around, then they can say, oh, this person's going to cooperate. So in future, you can both cooperate and you can then both reap the rewards of that cooperation. So, but if you show that you'll defect, then you know the other guy is going to say, oh, well, he's going to defect, is he? Well, I'll defect too. So, you know, you're going to get punished for that over and over again. So there's kind of an incentive to cooperate with the iterated prisoner's dilemma. And what Axelrod did was he invited game theorists who have thought about this and suggested what the best strategy is to use in this iterated prisoner's dilemma to get the best payoff totaled up over all the successive games that you might play. And so he got them not just to play it, you know, directly, but to write computer programs that expressed their strategies, and then he put those into a computer and held a tournament, and then saw what the best strategy was. So each program, each different strategy, played against all the other ones in an iterated prisoner's dilemma. So played, you know, dozens of games, and then he saw. Then they got the payoffs depending on what they chose in each game, and then he added those up and saw which strategy did best. And the strategy that did the best was called tit for tat, which is basically what its name implies. So it would just do what the other guy did, or what the other program did on its last move. So if the other program cooperated, then it cooperated. If the other program defected, it defected. But if the other program yes, so if the other program defected, it defected, but on the next move. But if the program then went back to cooperating, it would go back to cooperating. So it was always just copying whatever the other one did, tit for tat. And as I said, this came out the top. And Axelrod wrote about the features that made this the most successful. And that he said these are the generalized features that tended to be characteristic of all the more successful programs. So the first one was that, as he put it, I think, that they were nice, which meant that they didn't defect first. So on their first move, they would always cooperate. So they weren't the first to defect. So that was nice. Then the second feature was that they would punish bad behaviour by the other side. So if the other side defected, that's bad behaviour, they would punish it by defecting themselves on the next move. So you can't be a pushover, because then you'll end up here being the sucker who gets the worst payoff every time. And the third feature was that it was prepared to forgive. So if the other guy defected but then went back to cooperating, you would go back to cooperating. You wouldn't bear a grudge, as this tit for tat wouldn't bear a grudge. It would forget the past and just, you know, okay, you're cooperating now, we'll cooperate. Those three features led to the best outcomes. And so what you then ended up with was, with tit for tat, with other programs, it would tend to get into the cooperative mode. By being nice, ready to punish, but forgiving, it would be spent more time cooperating with the other programs. And so it came top, did the best. And so Axelrod's argument is that this is how cooperation can emerge in among animals and among people in human societies, that it emerges naturally just through the benefits of cooperation. Because if you don't cooperate, you'll end up, you know, you might take advantage once or twice, but if you keep interacting with people, you have this tendency to defect and not be nice, you will end up doing worse in the long run. But if you're more prepared to cooperate with people, you will do better. So just by your own self-interest, you will naturally tend to cooperate, or at least those people who cooperate, or those strategies that cooperate, will tend to spread in the population, and the ones that don't cooperate will fall behind because they will do worse. And he gave an example of how that is actually seen in a real world example, a real world scenario, was the live and let live system, as it was known in World War I, in the trench warfare. The opposing sides would shoot not at each other but at some inanimate object, and so they didn't shoot to kill, so they would deliberately not shoot the enemy, and in return the enemy would not shoot them. So they got into this cooperative square here. But that was, of course, not done with any verbal interaction. They didn't meet to discuss it, but it just emerged naturally, supporting Axelrod's idea that cooperation can emerge naturally in interacting populations. And what's necessary for it is the iteration of this game. And so how the officers, of course, it's not good in the war to have your soldiers deliberately not killing the other side. So the officers had to stop the live and let live system, and what they did was they moved units around the front on a regular basis, which meant that they didn't have long iterated prisoners' dilemmas where this cooperation could emerge. They were more like one shot. They were only there for a week. They didn't have time to iterate and develop this or move into this cooperative behaviour. Now, I should say that all these frameworks I've discussed, of course, have their critics, but what I've covered is enough for us in this introductory course. If you delve deeper into them, you'll find the nuances and the caveats about them. But nevertheless, they can give us an idea for some of the principles that lead to the achievement of cooperation and coordination in human groups, and that we identify as Gumilyov's ethnoses or civilisations, super styles based on certain practices and beliefs that everybody shares. So let's see a few points about that. So firstly, we can see the importance of interaction. That's like in the iterated prisoner's dilemma. More interaction is likely to lead to more cooperation. Your civilization of shared values is going to be among those people you're interacting with. And people beyond that are too far away for you to interact with, you have no reason to develop cooperative relationships with them or to care what they're doing. The second issue that arises from the things we've been talking about is the importance of social influence, imitation. What other people are doing is important. Because you have a tendency to follow what other people are doing. An experiment that investigated this involved asking people to rate songs, as you might do on Spotify or something. Gave people a set of songs, and they had to rank them or give them ratings. And but the ratings were shared, so people knew what other people were saying about which were the best songs. And so that's song ratings experiment. And the result of this was that certain songs emerged, or a few songs emerged as hits as a result of the experiment. They're Dragon Kings, much more popular than the other songs. But when they did this with different groups, which song emerged as the hit, as the Dragon King, was different in each case. So it suggested that it was that social influence, it was what other people were rating well, caused you to rate the song well as well. And so it led to this homing in on particular favoured songs in this case. But in general, homing in on particular favoured behaviours based on what other people were doing. What they found in this experiment was that there were some songs that never got picked, so there were some real stinkers, and then there were some songs that were better than the others and got picked more often. But nevertheless, there was quite a lot of arbitrariness to which song came out as the best in each case. The ratings were by no means reproduced across all the different experiments, so suggesting the importance of social influence in deciding which ones should be chosen, not their intrinsic properties. Third point is, we said earlier that culture is a form of communication like language, and so settling on certain stereotyped practices that everybody does, certain stereotyped ideas that everybody believes, creates predictability. You can understand what people are doing. So, if you see a young woman in an elaborate white dress, you can say, she's a bride, this is a wedding. You know what the situation is, you know what people are doing, you can understand their actions, and you also know what's expected of you. So coordinating on certain cultural traits is a matter of communications predictability. So, you know, in something like a civilization, it's millions, hundreds of millions of people. But if we belong to the same civilization, we have a shared values, we can meet any of these 100 million strangers and still have some reasonable idea as to what's expected of us and what, you know, what they're communicating back to us through their behavior. And a final point is that once a society has settled or coordinated on certain behaviors and ideas, then they're very robust, because these can be stable equilibria. Once everybody's doing a certain thing, you know, once everybody's driving on the left-hand side of the road, then it's very difficult to switch to the right side of the road. So there's a stable equilibrium. So it will tend to persist. So, you know, this applies generally to cultural traits. They're going to be very robust, tend to persist, and there has to be some huge pressure behind it to eliminate that stable equilibrium and cause the society to switch to something else. So this is why civilizations, you know, can last a long time.